guys, today we're going to look at 9.6, solving rational equations. And unlike expressions, equations, of course, will have an answer that we can get to where x equals something. Our essential question for today is, how do we solve rational equations? First things first, let's think back for a minute to our extraneous solutions. And extraneous solutions are solutions that do not work with the original equation. In other words, you get an answer for x, but when you go to plug it back in, it makes the equation not come out the right way. You get some nonsense answer, like in this picture where 2 equals 1. That would be an extraneous solution. They occur when you multiply each side of an equation by the same algebraic expression. What you need to know, the key part for you guys, is that you need to test all of the answers you get the first time and then get rid of the ones that don't actually work. Always check for extraneous solutions. Just plug it into the original equation. It's really easy. If it makes the equation true, it's a solution. If it makes the equation false, then it's extraneous. Let's say that your solutions are 2, -3, and 7, and the original inequality is x is less than 0. The question is, which solutions are extraneous? So we plug each of them in. We see that the solutions of 2 and 7 are extraneous because they make the inequality false. In other words, the only real solution, the only true solution is -3. To solve rational equations, you're going to use all of the skills you have learned so far. For example, let's say we have -4 over 5 times x plus 2 equals 3 over x plus 2. There's a number of different ways you could solve this one. You could notice, for example, that there's a 5 here, x plus 2, just x plus 2 here. You could put a 5 on the top and on the bottom, make the denominators the same. You could say, hey, I can cross multiply these. Ultimately, it doesn't matter as long as you do something that works out mathematically. I chose to cross multiply them. So I did -4 times x plus 2 equals 3 times 5 times x plus 2. You want to distribute. -4x minus 8 equals 3 times 5x plus 10. Notice I did the inner distribution first. I'm going to distribute again on the right, so 3 times 5 is 15x, 3 times 10 is 30. I'm going to simplify and solve for x. So -4x, I'm going to move it over, becomes 19x on the right. I have a -8, I'm going to subtract 30, move it over, so it becomes -38 equals 19x. Divide each side by 19, x will be -2. And I need to check for extraneous solutions. So if I plug in this -2 down here where I see the x, so there's a -2, there's a -2, I end up with 5 times 0. 5 times 0, I can't divide by 0, I get an error. So I know that actually -2 is not a solution, and so this equation does not have any solutions. Here's one for you to try. What's going to happen if you have 2x minus 1 over x plus 3 equals 5/3? Go ahead, hit pause, try it on your own, and then come back and see if you were right. Hopefully this is what you got, and you actually did find a solution. So again, we can cross multiply. 3 times 2x minus 1 equals 5 times x plus 3. 6x minus 3 equals 5x plus 15. Simplify and solve. X minus 3 equals 15, so x equals 18. We can plug in the 18 over here where the x is. So 2x minus 1 over x plus 3 becomes 2 times 18 minus 1 over 18 plus 3, which is 36 minus 1 over 21, which is 35 over 21. If we reduce that, we do get 5/3. So the 5/3 that we got and the 5/3 up here, they're the same number. Therefore, x equals 18 is the solution to this equation. One more example for you. Solving rational equations. Up here, we need to find a common denominator again because we are subtracting in the middle. We can't just cross multiply. So if I see this is x plus 1, I see this is x, I know that this is 1 over itself right now. I can pretty much ignore that part. I do know that I need x plus 1 and x to both be part of the denominator. So I'm going to multiply 4 over x, the left-hand side, times x plus 1 over x plus 1, this denominator over itself. This guy in the middle, x plus 1 with a 3, I'm going to multiply that by x over x to take care of this denominator on the left. 1 I'm leaving alone, and we'll see why in a minute. I can now simplify these things. So they have the same denominator, x plus 1 times 4 minus x times 3, 4x plus 4 minus 3x becomes x plus 4 over x squared plus x. And I also multiplied on the bottom to get this denominator to shake out over here. 1 is still by itself. If you think about it, if you multiply x over x with the 1, if you multiply x plus 1 over x plus 1 with the 1, you're still going to get 1 at the end of the day. Now we can solve for x. X plus 4 equals x squared plus x. And where this came from was we had x squared plus x on the bottom. Imagine if we multiplied this entire fraction by x squared plus x and multiplied the 1 by x squared plus x. We're essentially moving that denominator over here. So x plus 4 equals x squared plus x. If we move as much as we can over, minus x minus 4 minus 4, 0 is now on the left, the x squared stays the same, x minus x makes the x's disappear, but we have that negative 4 now. This is a quadratic equation. We can use the difference of squares instead of the quadratic formula to solve this. So instead of saying x squared minus 4, we can say 0 equals x plus 2 times x minus 2. So therefore the value of x is positive or negative 2. We have to check for extraneous solutions, so we'll start with the negative 2. We'll plug it in. The original equation, 4 over negative 2 minus 3 over negative 2 plus 1. 4 over negative 2 is negative 2. 3 over negative 1, well, negative 3 over negative 1 is positive 3. Negative 2 plus 3 is 1. 4 over positive 2 is 2. 3 over 3 is 1, but it's a minus sign, so minus 1, and it becomes 1. So each of them shakes out to be 1. So therefore, both positive and negative 2 are solutions to this equation. Last but not least, we have a you try it. Go ahead, take a moment to write this down, hit pause, try it on your own, and then come back and see how you did, and I'll go over it with you. Welcome back. Hopefully you're going to get this same answer. It's going to take a little while to explain it. So first thing we want to do is fix the middle denominator. This is out of order and it looks kind of crazy. We want to get it looking like this, and we practiced this back in 9.4. Once we do that, we can more easily see what's going on. Next step is to factor the last denominator. Again, that difference of squares is coming up again. And now we see, oh hey, x minus 3. Oh hey, x plus 3. There's also a negative 1 here. I didn't write the 1, but you know it's there. So when we find a common denominator, we got to keep x plus 3 and x minus 3, and we need that negative 1. So on the right-hand side, all this guy is missing is the negative 1. So negative 1, negative 1. In the middle, all this guy is missing is the x plus 3. So x plus 3, x plus 3. On the left, he's missing both the x minus 3 and the negative 1. So x minus 3, negative 1, x minus 3, negative 1. So that's how we ended up finding that common denominator. After that, we can combine the left numerators. So 2 times x minus 3 times negative 1 plus 5 times x plus 3. We can simplify those left numerators. all of this stuff simplifies down to 3x plus 21. And if you think about it algebraically, whatever this is divided by, let's call it a, equals whatever this is divided by a. We can ignore whatever a is here, whatever a is there. If we're dividing by the same thing on either side, it's not going to make a difference in the top, since we're treating both sides the same. So the beautiful thing is we can just axe the denominators. We can ignore them. And we're left with just the numerators. 3x plus 21 equals negative 6. Subtract 21 from each side, so 3x is negative 27, so x is negative 9. Last but not least, check for extraneous solutions. Plug that negative 9 in for every value of x in the original equation. Mind the parentheses here. It's negative 9 times itself squared, which is positive 81 minus 9 is where we get that 72 from. At any rate, it works out. So therefore, x equals negative 9 is the solution to this equation, and I hope it's the one that you got when you tried it on your own.